Hello and welcome back to the 3D Amateur channel. Today we're finally going to be installing Octoprint on a Raspberry Pi, and then we're going to be attaching it to the 3D printer using a case. So I managed to print both parts of this after the failure we had last time, which ended up in me having to rebuild the Ender 3. We have also modified the cover to actually have an arm for the camera. So all I've done is I've taken this model into Tinkercad, removed the lovely Lego figure there, and I've just assembled an arm onto it, reduced the size of the Aperture Science logo, kept the Lego top, and then reprinted that. What we then need to do is also get some fans for the case and a camera for the Raspberry Pi, as well as all the nuts and bolts that we'll need to assemble this together, and of course the case for the camera itself. Now, I did experiment with the idea of using a chain cable to keep the cable for the camera kind of safe and secure, but honestly, as I'm not going to be using this all that much for time lapses or anything like that, which we'll explain a bit more as we go through the video, I've decided not to use it. Plus this is very difficult to attach to this. It's not the easiest thing in the world to do, and I have a feeling I would end up either breaking this or breaking this, and it would just be a lot of hassle for not a lot of reward. I may revisit that in the future, but for now we're going to leave that aside and not use it. So the first thing we need to do, which I have already done, is open up the Raspberry Pi. And as you can see, I've attached some heat sinks to the main processor and the USB controller there as well. I will leave links in the description for these. I already did put one heatsink on here, but I had to replace it because once I put the fan into here, I realised the heatsink was actually too tall, and I wanted to have both passive and active cooling, just in case. So we have that, we have that. Let's get the camera out. And the camera ribbon. So I've removed the stock ribbon from the camera purely because this is way too short, so we don't need that. Luckily, the one that I ordered come with quite a few additional spare ribbons, so let's pull that out. And we need the outside one here. So this should be long enough to reach up and down from the Raspberry Pi to the very top of the Ender 3. So let's roll that one back up and move the rest of these aside. I suppose we ought to start assembling. So the first thing we need to do is pop the Raspberry Pi in here. So nice and simple. And then this is going to be screwed from the bottom of here right the way through into these four holes here. But before we do that, we really need to pop the fan in. And again, I will leave links in the description for all of these pieces that I have used, and links to all of the Thingiverse files that I've modified and the Thingiverse files I haven't, to use this to get this working. So the first thing we need to do is work out where that's going to go, on there and on there. Now the two pins that it's going to use are going to be these two on the outside, sorry, on the inside here. So we are going to need to hook them up in a moment, but first let us screw this in. So we need the smaller screws here, and they should be able to go right the way through there, onto the other side, and then attach a couple of bolts on the outside there, he says. A couple of bolts on the outside there, and then we should be good to go. Which is not the easiest thing in the world to do on camera. There we are. So I'll be back in a moment once I've just put the rest of them four in, rather than you having to sit through all of that. And now that we have the fan fully screwed in with the bolts there, the next thing to do is going to be to attach this onto here, and we need to correctly put the pins in to make sure that we get the 5V for the fan, and then once this is closed we can screw it in from the underside. So we do need to go red pin and black pin. So red pin on So the red pin goes on the outside connector, one in, and then the black pin goes, or whatever, if I was actually in front of the camera. So the red pin goes one in, so on this one here, and then the black pin goes on this one here. So let's get them connected. And there we go. So black pin and red pin on the outside. Now we can close this case up, and we have everything we need on the outside there and the fan connected on the inside. So the next thing to do is use some M3 screws here, sorry, M2.5. Again, I will leave all of the pieces in the description for you to have a look at, and Amazon links on where I bought them all from. So now let's just tighten this up. And there we go. Now that's all connected and all tight. I've realised that we actually need to put the camera cable in before we tighten it. So let's undo that, and then we're going to have one side of the camera cable go into here, and then we'll tighten it back up again. There we go. So now that we have it undone again, let's try this again. So the camera connection will go into this slot here. And then we need to feed the cable through this hole here. And then once again, get this connected and screwed together. So now we have all of this connected. We need to connect the camera itself, and that is the same connection as on the Pi. So we need to pull this little cable out here, slot this in, and then push it back down together. And there we go. So now we have that connected. We also need to put the camera case around here, and then that will hold onto here, yeah, that way, and it will then go onto the Z-axis, and the camera will be pointing down, and it will rise with the Z-axis. So let's get doing that. Now I have placed a little bit of foam back material in here, because when I was putting this together for the test fittings, it kept popping off the camera connector here. So that's a really fairly loose connection, and obviously I wanted to make sure that that stayed connected, so I've popped that in there to make sure that pushes that down once we pop this on. So this is just a press fitting into there, and then the same on the back here. This will just press together with a little bit of force, and it all snaps together to hold the camera in. Pretty sturdy. So now we need another screw to go into here, which is what this one is for. So that should slot into there and into here. So let me get this connected and I'll be right back with you. And there we go, so that's all connected. We have a little bit of movement on there, but we need to just undo that, and then we can adjust the camera angle however we want, and then just tighten that back up again, and then it will hold nice and tight. And then, as I said, that will go on the Z-axis, and we should have a camera that can rise up and down with the printer. I'm quite excited to get this going. So the last three screws here, these are to go in the side of here. So the Pi itself will be mounted by these three holes, and it will be mounted on the left hand side of the Ender 3, just using the V slots. So we have a couple of little hammer nuts here. There we are, and they will basically attach into the V slot rails of the Ender 3 and tighten this to it. So what we need to do is pop them in there, pop these on here, well, not too tight, and then we will be ready to head over to the Ender 3. And there we go. Right, so let's go and prep the Ender 3. So here we are at the Ender 3. Now, I have already removed the old one, as you saw in the video previously, and the first step in assembling this together is to remove the V-slot cover here. So we're going to unscrew this bit, remove the V-slot and put that back. And I've already positioned the USB cable, so I've got one plugged into the front here that runs to this one here, and that'll be plugged into the Pi, and then one running around the back plugged into the power supply. Now I do want to thank one of my viewers for commenting on the Ender 3 power upgrade video, and he did come up with a great idea. He said to remove the magnets and actually drill through the hole inside the box, and then I can use where them two screws went in to actually attach the box to the back permanently. So I have done that, although you can't really see it from here, but the box is now attached permanently on the back of here. So thank you very much for that. It's comments like that and ideas like that as to why I started the channel, because I would not have thought of that myself. So thank you very much. I'll pop the comment up on the screen rather than butchering your name, so thank you for that. So let's get started with this and unscrewing here. So now that that's done, let's get this positioned on here. So this should just slide over and then hold on nice and tight, and then that will be pointing down to there. Now obviously when the print starts this is going to block it off a bit, but hopefully once it starts actually coming further here we should be able to get quite a good view on it, and I'll show you what that looks like when we go back to the software side of things. And then we should just be able to get this on here. So simply like that. And then these should tighten up just in here. To give us a nice solid fitting. Now I'm going to have to move this up just to connect these ones in. So let me show you how this should work. So as we move the Z axis, the camera will go up along with it. And what that'll mean is as it's printing we'll always have a view of the top of the print from the camera up there. Let's get these other ones screwed in. I'm thinking now I probably could have got away with a shorter camera connection there. But that being said though, if we do end up doing a print that goes right up to the top, then we might end up in a bit of a sticky situation. So as you can see, that's nearly to the top of there. And we have actually still got a bit of play here, so we may shorten that, but for now that is perfectly fine. So with this connected, we need to plug in this cable here. So this USB cable will just plug into one of these, just like that, and then we'll keep that cable nice and tidy around the bottom of here. And then the other power cable will be plugged in here, but I can't really reach it with the camera in the way, so I will get that plugged in, and then we should be good to go with the software. So we'll need to flash the memory card, and then that will plug into the back of here, and then that will have the Octoprint software on there. So I'll show you where to download that and how to do that, and then we can access it remotely and see what we can see. So I'll join you back over at the computer where we can flash the memory card. So now we have to install Octoprint to the Raspberry Pi, and to do this we'll head to octoprint.org, go to the download button, and then it'll give us the option to download Octopi 0.18.0. This is the latest version, and the latest version will always be here. So hit download on that, and that'll download as a zip file, and that'll be the image that we need to burn onto the SD card. Underneath here, it will give you some more information on how to connect to your Wi-Fi and how to create an Octopi account and so on. I won't go through that in detail, but you can go to octoprint.org and have a look for yourself if you plan on doing this. What we do need, however, is a micro SD card flasher. So they recommend Etcher, which I downloaded, and this is a really simple and straightforward program. Just download the exe file and it opens up like this. So all we need to select is flash from file, and you can see I've downloaded and extracted the image file here. So we'll select that. Then we select our target, which is our micro SD card here, and then quite simply hit flash. And that'll start the flashing process, which may take a little while. So once that's done, we'll get that plugged into the Raspberry Pi and I can show you the Octoprint interface. So now that we've successfully installed Octoprint, we need to access the Raspberry Pi using its local IP address. In my case, it is 192.168.1.38. This can be found by accessing your router, and you'll be able to see the list of all your connected devices, and it will be on there. Now usually you would be taken to a login page or an account creation page. I already have created the account, so it logs me straight in, and this is what your main page will look like. So once we're in, we can see our printer is connected, and you can see I have already installed Octolapse. Now we also have an option down here to upload any files or create a folder, and we can also upload to the SD card if we have one inserted. So what we're going to do is just run through quickly the interface. So if we go to control, we can now see the Raspberry Pi camera there, and we can actually move the hot end using the controls underneath here. Although let's home that back up again. And then what this will do is just enable us to remote monitor any prints. So if we're not in the room, and we can just keep an eye on them. We then also have the time-lapse function that's built in, although this is only done at a rate of how many frames per second, so not the best. But Octolapse is by far the best situation, because what this will do is it creates a stabilized time-lapse. As you can see, I've done one here of a previous print while I was testing, and it enables it to get the hot end out of the way, or in our case, using that switch that I had installed on one of the previous videos, it would enable us to trigger that switch. And that switch is then connected to a DSLR camera, and this will enable us to do high resolution time lapses. So to install this is relatively simple. All we need to do is go up to the settings menu, and then on the left we'll have a plugin manager. And quite simply, we just search in here, Octolapse, and then from there we can just click install. As I said, I've already installed this, so that's fairly straightforward. It installs, it will reset the Raspberry Pi, and then once it's installed, you have the options here. So now if we wanted to print something, all we would need to do is upload it. So I already have a 3D Benchy that has been sliced here. So we'll open that. That will upload, and we have the default settings in here. Now, what I want to do is actually change some of these, but I'll show you why. So once this is uploaded, we can load it to the printer. So then that brings it up here, and then we can hit print. Now with Octolapse enabled, what this will do is it will give us an option of where this is going to be. So if we have a look, we can see where it's going to go for the snapshot, which is this blue little circle here. Now we don't want it to go to the left, because what that means is it's going to end up printing, it's going to go to the left, and it's not going to trigger our DSLR switch. So let's cancel that. So what we want is we want center right. And then we want compatibility. So what this will do is it will take a snapshot on every layer, and it will keep the quality of the print at a high. So as it goes through every layer, it will try and figure out where the best place is to move the hot end away to take the picture, and then it will be able to keep the quality of the print while getting the time lapse. There are other options in here, so things like fast, where it will take move the hot end from the closest point to the switch as possible, which we don't want. We want the print to still look nice, so we'll leave it on compatibility. The rendering options are not going to matter because that'll be down to us and the DSLR camera, but if you was using the Raspberry Pi camera, you can then say that you want it to be 30 frames a second, 60 frames a second, so every layer will be one of them frames. So we'll leave that as is, and then we need to hit print. So what this will do, again, process, and now we can see that the snapshot is to the right. So this will move all the way over, trigger the DSLR, and then take a snapshot. So we're happy with that. So what we want to do is hit accept and continue, and then that will upload the file to the printer and it will start printing. So now if we head over to here, we can see that the bed temperature target is now 60, and that will start heating, and then the extruder will start heating, and everything that you would do from the printer you can do directly through this interface, all while keeping an eye on the printer itself. So this can be very handy if you decide to have 2 or 3 printers in a basement or in another room, and you can still work with them while you're away from the printers themselves. You could be sitting in an office or in the living room on your laptop and still be able to print stuff even if your printer's elsewhere. So very, very useful. This can also be done remotely, although I would never advise to ever print remotely or leave a print running without anyone nearby to cancel it if need be. So with that in mind, let's take a look at the result. So now we are over at the printer. We have the switch which is wired all the way down up to the DSLR here, and then that will be triggered to take a snapshot at every layer, and we should just about be heated. And there we go. I do apologise for the shaky camera, as I am doing this handheld rather than with the tripod because it's being used by the DSLR. So let's have a look. So the first layer starts to go down, and then we get a snapshot. And the results of all this, I hope you'll agree, are quite impressive. We get a nice high resolution time lapse, although I do need to frame it better for the future videos, and we also have the clock behind, which is an addition I made in an upcoming video. So if you'd like to see that, then please subscribe, and you can ring the bell to be notified when that video goes out. If you did like this video, please like it, and if you have any suggestions or questions, then please leave them in the comments below. Thank you very much for watching. I hope to see you next time. Take care, and goodbye for now.